Welcome to the webinar. Thanks everyone for joining. My name is Eric Dean, and I've been with the company for about 20 years. I work in business development, and as such, I work with customers like you every day on new applications with our products. And today I'll be discussing specifically electrification solutions for EV fleet vehicles. And as mentioned before, if you have a question, use the question button at the bottom. To submit that question, I'll answer all the questions after the webinar. So today, first, I'll quickly cover some information about Parker Lord, where we manufacture things and the different markets that we serve. Then I'll move into more detail about the solutions that we offer, fleet vehicles in the e-mobility space. And then, like I said, we'll wrap up with Q&A. So at Parker, we pride ourselves with moving at the speed of our customers and able to support rapid prototyping and scale up, which is really critical as these industries electrify. Customers are moving faster than they ever have before. With our history in electrification, we do carry a broad portfolio of proven off-the-shelf products and also live technical support either through the phone or in person with our application engineers that can visit your facility and help with product selection, testing, and ramp up. Here you can see our facilities that are dedicated to this space. Obviously we manufacture for our domestic customers in Sagertown in Pennsylvania and Indianapolis, Indiana, but we also have testing and manufacturing across the globe in Hückelhoven, Germany, Kofu, Japan, Shanghai, China, and even in Brazil. Those support all the different regions that we do business in. And we've also localized some of our R&D efforts and capabilities where our customers value it most, mainly in Asia and obviously here in the US. We benefit from serving a lot of diverse customers in the electrification market. We commonly see trends in the automotive industry that develop products for those OEMs, and then we deliver those products to the bus market or the truck market or even aerospace after those are fully commercialized in automotive. And like I said earlier, having been involved in the earliest parts of the automotive electrification space, we do carry a lot of products that are going to be directly applicable to the applications that we see for fleet vehicles, the heavy truck market and the bus market, as those turn more and more electrified. Speaking of products, that's it for the overview. So now let's dive into the products that are specific to EV fleets. So at Parker, obviously, it's a gigantic company with 60,000 employees and over $15 billion in sales. So Parker Hannifin has a new brand called EV Onward that helps to summarize and collect the products that are directly applicable to electrification opportunities. Those include things like sealing and gasketing, EMI shielding, but today we'll focus on the products that I'm directly responsible for, and that includes thermal management materials, structural adhesives, and coatings. You'll see here, electric fleet vehicle solutions as applied to a truck include a lot of different solutions. But today, for the sake of focus, won't go through all of these applications. We'll focus on the battery pack, the charger, inverter, and the charging handle, and maybe a little bit of the charging station. And we'll primarily focus on those things like potting and encapsulate materials, thermally conductive gap fillers, thermally conductive adhesives, coatings, and structural adhesives. So let's jump into our first category of adhesives and thermal management materials. This includes a lot of different technologies, including gap fillers, adhesives, potting encapsulants, and low-density encapsulants. Thermal management has been a key area of product expertise for Lord for over 30 years. And as of the last 15 years, we've seen power electronics, electronic vehicles, energy storage increasingly require high performance, reliability, and safety. And if designed properly, these thermal management materials provide just that. With regard to fleet vehicles, reliability, safety, total cost of ownership are critical. Proper thermal management impacts all of these. These materials directly increase the efficiency and the life of your applications while also reducing the risk of failure. So these applications in battery packs, more specifically, act as a thermal link between components to ensure a proper heat flow. Our liquid dispense gap fillers improve thermal resistance versus gap pads in cooling plate applications. Potting and encapsulation materials have high thermal conductivity at relatively low viscosities, ensuring, even void-free potting of power electronics or battery modules. Thermal adhesives provide, all the strength and rigidity of structural adhesives while also conducting heat. So they can be very good options for cell attachment. And finally, low density encapsulants can provide thermal and electrical insulation with minimal weight. So our first application is between a battery module and a cooling plate. Here, the use of a gap filler is critical to draw the heat out of the cells. Liquid dispense gap fillers can ensure no air pockets while also accommodating tolerances across larger surface areas where gap pads may not perform as well. These also come in a wide variety of thermal conductivities. You'll see here on the slide, SC1200 and SC1600, that's a 2-watt material, and a 3.4-watt material. We have a lot of different variations of those materials to kind of provide you exactly what you're looking for. Moving up in the design, for those that are working on cell-to-packs designs instead of modules, we offer solutions for those as well. Here, depending upon the design, we may recommend different gap fillers that may feature like reworkability or higher adhesion or higher elongation. We can also offer products that are urethanes or silicone, depending upon your heat or other chemical resistance kind of requirements. Additionally, low density encapsulants have become increasingly important for safety as batteries have become, ever more energy dense, and vehicles are larger and larger and have larger and larger battery packs. Here, the top cell foam is actually designed just to be on the top of the cells. It provides electrical insulation and protects the wire bonds. But in the event of a thermal runaway, it's designed to allow, a single cell to vent through the foam without jeopardizing the rest of the foam. And the rest of the foam will protect the other cells from the electrolyte and the heat expelled from that one cell, in a sense, preventing thermal propagation. The intracell material is meant to fill the entire battery module. It's a low viscosity, so it flows into all the small gaps. It's designed to prevent lateral heating between batteries. Also add structural rigidity to the pack, and most importantly, isolate thermal runaway to a single cell, similar to the top cell foam. So switching gears to charging equipment, you'll find Cooltherm products in charging handles to reduce hot spots by evenly dissipating the heat, as well as providing strength and ruggedness to an otherwise hollow plastic handle. Additionally, you'll find our products in onboard charging equipment. Converters and inverters are commonly potted with our products, while also using a gap filler between the component and the outer housing that acts as a heat sink. And here you'll see these are the key thermal interface materials for fleet vehicles. At the end of the day, these are a subset of our products, and you'll see down the left-hand side there in the gap fillers, a variety of chemistries and thermal conductivities that I spoke to earlier. Again, these are just kind of like the high runners. And of course, all of these are UL rated and come in various package sizes, from cartridges, pails, and drums. And they all utilize industry standard MMD equipment. And on the right-hand side, same story with potting and encapsulants, variety of chemistries, variety of thermal conductivities. These are all UL rated. They all come in various package sizes and all use standard MMD equipment for potting and encapsulation. Now talking about structural adhesives, Parker Lord has been bonding vehicles together for over 40 years. So it's no surprise when assembling large aluminum boxes full of critical components, there are going to be a lot of key applications for adhesives. Our first application at the cell level, TC2002 is one of our thermally conductive adhesives that is very commonly used to bond cells directly to the cooling plate. Here you get thermal conductivity plus structural strength of an adhesive. TC2002 was formulated to be non-sag, so you can, apply it vertically or even upside down, and it cures quickly so that you can have the manufacturing throughput that is often required for, large volume fleet vehicle kind of production lines. And not only that, but it's also been used in the battery building for years. It's a workhorse product for us. It's a workhorse product for companies to consider in this particular application. So moving up from the cell to the cell carrier, a lot of cylindrical cell designs, it's extremely common to have a plastic carrier tray or a cell holder to organize and place the cells within the pack. LORD 5206 is a structural adhesive that is commonly used to bond nickel-plated cells to the plastic substrate of the cell carrier. Its viscosity and thixotropy and cure speed have all been optimized for high volume production processes. And then adding on to the carrier tray, you can see the same LORD 5206 is used to bond the current collector to the top of the cells. This will improve the stability of the wire bond, because the current collector doesn't move relative to the carrier tray, which doesn't move relative to the cells. And here again, precise application, fast curing, high strength are all critical features of LORD 5206, and even Max Lock, which is listed there, and both or either could be used for this application. Moving up from the cells, we also offer modular or enclosure sealants where designs are not able to or do not want to incorporate like mechanical fasteners or an elastomeric seal. We offer both structural and non-structural sealants that will act as a continuous barrier resistant to moisture, chemicals, and the environment. Also, these sealants can be rapidly dispensed and fully automated. They can reduce the number and frequency of, as I mentioned, mechanical fasteners or spot welds or even completely replace MIG welding. And so wrapping up adhesives, this is the overview of those adhesives that I think would be key for fleet vehicles. It's safe to say there's a lot of applications for adhesives, in addition to those mentioned when looking at flanges, attachments, cross members, lids, modules, cells, etc. Adhesives can be a great alternative to increase strength, eliminate fasteners, eliminate welding, and most importantly is bond dissimilar materials. So like metal to plastic, cell to plastic, but also metal to metal. On the right, I will mention that our testing facilities commonly do testing for customers during their design process. The test here looked at glycol immersion for LORD 850. And as you can see, we submerged some metal coupons bonded together with LORD 850 for 3 weeks at elevated temperature. And you can see that the strength did not change in any statistically significant way. And the failure mode, most importantly, stayed 100% cohesive during that whole time frame. My last product category for the day is coatings. So here we are looking at dielectric coating for cells, cooling plates, and enclosures. The dielectric coating is becoming more and more critical in battery designs as energy density continues to increase. Free space is eliminated, driving cells ever closer to other metallic components. Key requirements for dielectric coatings typically include high dielectric strength, about 3.4 kilovolts, or and even at high humidity levels. Good adhesion to both substrates as well as the mating gap filler or structural adhesive, or even thermal pad applied on top of it. And so dielectric coatings has become a very critical component in the stack up of and the building of battery packs. So LORD JMC 700K is one of our thermally cured options. It's most commonly used on cooling plates or cooling ribbons. It's applied at around 90 microns, and that'll give you what most OEMs require for dielectric resistance. It's spray applied using standard HVLP equipment and can easily be automated. It has good flexibility and good crack resistance and can withstand temperatures in excess of 180 C during the operation of its end use. And it's a really, really good alternative to powder coating, where powder coating struggles around maybe edge coverage because of its electrostatic deposition or because of some cracking or something like that. CPL UV is our UV cured dielectric coating, which cures in just a couple of seconds. It benefits from being 100% VOC free and also being spray applied with standard spray equipment. It targets very similar thin application thicknesses like JMC. It was also developed as a replacement to PET films, which are expensive to automate, tear easily, and generally have low adhesion. to the substrate and other adhesive materials used in conjunction. SIP-BL UV was formulated specifically to have good edge coverage all the way down to, a 0.03 millimeter radius. So very sharp edges can still be coated quite effectively with SIP-BL UV. In addition to coating individual cells, SIP-BL UV can be used on cooling plates to replace thick powder coating. So long as there's direct line of sight to UV light, SIP-BL UV can be used anywhere that you want to use it for dielectric protection. This could essentially take a potential powder coating process, which generally takes about 40 minutes with ovens, to under a minute with just UV light. It's a very compelling technology. And with this recent focus on dielectric coatings, and if these are interesting to you, I did co-author a white paper. It was published just a month ago. It focused on the evaluation of our solutions versus industry common PET films and powder coating solutions. It goes into really significant detail on the results of various properties like breakdown voltage versus thickness, edge coverage, thermal conductivity, et cetera, et cetera. You can find this white paper on our website. You could Google for the white paper or reach out to me directly and I can send you a copy. So to sum it all up, there are a lot of complementary products offered by Parker Lord, specifically designed and specifically good for fleet vehicle OEMs. Coatings, low density encapsulants, thermally conductive gap fillers and adhesives, structural adhesives and sealants. When you consider Parker Hannifin's additional sealing and EMI technologies, we have become a one-stop shop for many of your applications and can help you from basically day one of your design process. So with that, I look forward to working with you or with each of you one day. And so thanks. And in just a second, we'll start to answer some questions.